Okay, guys, so in this video, we'll be talking about the 2024 Atlantic hurricane season. We will be doing a full review of the entire season from start to finish, give my own thoughts on it, and we'll try and get to as much of this as possible. I did not make enough updates during the season about what actually happened. I mainly stopped videos after around Helene because I had college work to catch up on, but since that last video, we've had Helene, we've had Milton, we have Kirk, Leslie, Isaac, Gordon was another one. We had Raphael, we had Oscar, Nadine, and we'd had Sarah. Those are the last names. I did not make a video on Beryl, and I did not make a video on the first half of the season, pretty much. But we'll go into it. So, the 2024 hurricane season will go down as a very active season. Officially, it's hyperactive because the metric for ace points, which is 162 for this season, is above the hyperactive threshold of 159.6. So this hurricane season, this hurricane season is the first hyperactive season, not the first hyperactive season, but it's another hyperactive season in the 2020s, the last hyperactive season being 2020. So it's the first hyperactive season since 2020 in the North Atlantic Basin. So for this season, we'd had a season with 2 Category 5 hurricanes. This is a season that has had 5 majors, so here, the full stats. This season has 18 named storms, which is above average, 11 hurricanes, which is above average, close to what the top end seasons usually have, and we had 5 major hurricanes this year. Total fatalities are around 400. I will make a quick summary of where most of these named storms came during the season. The first major hurricane, Beryl, was at the very beginning of the season, around July. Earliest Cat 5 on record. Ramaged through Carriacou, the Eastern Caribbean. Made through. Did not make a landfall in Jamaica, but the eye wall was over Jamaica while it was passing to the south of the island. And then it made a landfall in Yucatan as it was weakening due to shear and some dry air getting into the system. And then the system would weaken to a tropical storm as it enters the Gulf and would try to reform, and then it would make a Category 1 landfall around Matagorda, Texas, before leaving Houston, the Houston metro area, without power for a full week. It also led to the most tornado warnings issued by the Shreveport National Weather Service Office in Louisiana. After that, the season had a pause. So we had Alberto, Beryl, and Chris within the first 2 months of the season. Then August came, and then we had Debbie in early August, and that was a storm that impacted Florida. It was a tropical wave. I'll get my mouse out here. It was a tropical wave that originated out here. I need a better color. It originated out here in the main development region. It was a dry wave. Debbie's precursor did not have much precipitation with it originally. It was dry. It had just come off Africa and had a lot of dust wrapped into it. It only really started gaining convection as they moved westward through the Caribbean, and then finally, as it moved around Cuba and then came off the northwest coast of Cuba, then it actually developed into Debbie here, and then from there, it slowly moved into the Big Bend of Florida, and then became a Cat 1 hurricane before landfall. And the big story with Debbie was the amount of rain that had dropped over the Carolinas. Total damage estimates for Debbie are $12 billion, which with about $2.5 billion of that happening in Canada with large-scale flooding from Debbie's remnant as its remnant circulation moved up the eastern seaboard. Then we had Ernesto. Ernesto was a Cat 2 hurricane at peak. It began as a tropical wave out here. Its precursor probably started somewhere in sub-Saharan Africa because the monsoon season over there was really strong this year. And that entered the northeast Caribbean's tropical storm, dropped rain over Puerto Rico and islands, became a hurricane as it exited the Caribbean, became a Cat 2, but weakened as it made landfall in Bermuda, weakened down to tropical storm, and then re-strengthened into a hurricane as it moved out to sea, while just scraping the coast of Newfoundland up here. Then the season went into a bit of a lull, so we could talk about that here. The 2024 season went into a bit of a low period of activity after Ernesto up until about Francine, but activity didn't really kick up until Helene, really. The main reason for that is wind shear in the basin increased. The Madden-Julian Oscillation, which is an atmospheric pattern in the tropics that controls weather air over an area, is rising, which leads to thunderstorm development and precipitation, or sinking, which leads to dry air and plenty of sunshine. The Atlantic was had a pretty unfavorable phase of the Madden-Julian Oscillation for that amount of time. In addition to that, the actual African easterly jet and the monsoon itself was displaced pretty far north this year compared to normal. In hurricane optimal conditions, at least according to Dr. Klotspot's graphic, the optimal hurricane transition line, where most tropical cyclones in the eastern Atlantic can form off of, is when the tropical monsoonal trough is positioned like this, around and above 10 to 15 degrees north, or more around 12 degrees north, and then bends back slightly over Senegal and into the Western Sahara. This year, by contrast, the tropical wave train was positioned much further north, around 20 degrees north, 25 degrees north is in Morocco. This had led to a lot of rain in the Sahara Desert, so a lot of places in the southern Sahara got a lot more rain this year than what they are normally supposed to get. And that also means waves came off the continent much further north than normal for hurricane development. So, one reason that matters is because up here, off the coast of northwest Africa, although this is West Africa, this is Northwest Africa because Morocco's right here. So, up here, the Canary Current comes down. And even though the Atlantic was record warm this year, this water is still cooler and less stable than the tropical water down here, for example. And the air masses coming down from the mid-latitudes coming away from the Iberian Peninsula, Spain, Portugal. These air masses come down into this area and keep it relatively stable. So the air is not only drier, the air is more stable and there's less moisture to work with. In addition to that, dust coming off the Sahara itself, it gets kicked up and pulls in dry air with it. So it caps the tropical waves coming off. And then because these tropical waves come off, any waves that decide to come further, that were able to get further south, because this dust is already present here, this dust was able to transition directly into the monsoon wave trough and cut it off like that. So that's why for most of September, until the wave started moving further south as the seasons changed, and the intertropical convergence zone moved further and further south, allowing waves to come off further to the south where they're normally supposed to be, so they're not pulling in Saharan dust, they're not pulling in mid-latitude dry air. That is when the season really kicked off. Once we had Helene, and then the MDR had the main development region here, which I'll box in with this pink color. The main development region here had a major boost in activity. Once the Madden-Julian Oscillation lined up, there was rising air. The tropical waves came off at the bright latitudes. The upper atmosphere also cooled down. That's one thing I didn't mention. The upper atmosphere over the Atlantic, for the most part, was still very cold, but it made the atmosphere stable because the air in the upper levels of the atmosphere was too warm to support convection, despite the ocean being record warm, because upper levels of the atmosphere are around 2 degrees Celsius warmer than what they should be. That was just enough to stop convection. But as the season changed, as we got into October and the sun angle decreased and the upper atmosphere didn't have as much warmth, then the cap in theory broke off, and that's why we saw the record activity after in late September and into October, where we had a lot of named storms back to back to back. And we're gonna get into that right now. We'll do a. I already discussed Beryl. I discussed Beryl. I discussed Debbie. I discussed Ernesto. I did not really discuss Alberto and Chris, but just so you guys know, Alberto and Chris developed in this Bay of Campeche area because of monsoonal forces. The Central American gyre helped spin some of these storms up as energy. Usually what's going to happen, I need a brighter color. Usually what happens in around Central America in the early part of the hurricane season and the late part of the hurricane season is you have westerly flow coming off the Eastern Pacific, and you have trade winds coming in from the Caribbean moving north and then bending in this sort of fashion. And then over Central America proper, you get a low pressure system. And then from there, you have rising air convection. And then inside of this gyre, you will have tinier balls of energy that spin around, and then they will eventually break off and become tropical cyclones. Both Chris and Alberto are cases of this, where a piece of energy from the gyre span out into the Bay of Campeche, developed in this region, and then from there moved straight into Mexico and dissipated because of the mountains there. Okay. Now we'll move on to Helene and, well, not Helene per se. We'll move on to Francine. So Francine, if you guys don't know, is this storm right here. I can actually scroll through the Wikipedia article and show you guys what exactly I mean. But Francine was a Category 2 hurricane that impacted the state of Louisiana directly. This was actually one of the first tropical waves that we were really expecting to develop in the main development region. Yeah, so I'll pull it up. This is what it looked like on satellite at peak intensity. But what isn't shown here, I can actually pull it up here. Francine, a tropical wave that precursed Francine, came off of Africa, but it didn't really develop in the main development region or the Caribbean, despite models saying it could, due to those harsh factors of wind shear, dry air, etc., hampering the basin. So it only really got its act together once it entered this Bay of Campeche area, and then it was able to develop. Now, the waters in the Gulf at the time were warm. This is too early because this is in June. I think I have the September map open. But when Francine got into the Bay of Campeche, it developed, and then it made a track like this. And then, I don't think it made a track like that, actually. I think it made this part of the track is right. But I think it went in like that, where it made a landfall in southeastern Louisiana as the Cat 2. The main reason Francine was capped was because there was a trough over the central United States, imparting some wind shear onto the system. So this wind shear stopped Francine from really becoming a major hurricane. Very quickly, despite a gain in Cat 2 intensity at landfall. Plus, Francine wasn't super organized. It took a while to get organized because the system itself didn't develop out here and needed time to consolidate in the Bay of Campeche, which meant it only really had about 1 to 2 days to really strengthen before it made landfall in Louisiana. That's also not compounded by it's also compounded by the fact that dry air coming off of Mexico, the interior of Mexico, also made it into the circulation and slow its development down a bit before it really got its act together right before landfall. This was the same thing that happens to Beryl, except for Beryl. Beryl was already, I'll draw it this way. Beryl was already a bona fide major hurricane in the Caribbean. It was weakening down as it the Yucatan, but once it got into the Gulf, it was a tropical storm that was trying to re-strengthen. But this same dry air prevented Beryl from really strengthening until that last 12 hours before landfall, where it became a strong Cat 1, and then it went up like that. That was Francine. Gordon was also out here milling around in the open Atlantic. Conditions for it were not that favorable, considering there was more dry air out here, and the waters in this region are not as warm as in the Gulf or in the Caribbean, simply because it's the subtropical Atlantic. I think I have that map pulled up. I don't. I have this map pulled up, though. But yeah, for Francine, sea surface temperatures was never really a problem. Neither was it for Helene. That did attract something like that. It wasn't a problem for Milton. Milton's track was not like that. Milton's track was like this. No, Milton's track was like this. There we go. Yeah, Milton's track looked more like this. But in general, once we got late season, sea surface temperatures throughout the season were never the issue. It was mainly atmospheric conditions that led to the storms not really getting their act together until late in the season. We'll get into Helene now, because this is where the big damage totals after Beryl and Debbie really start coming in. Helene is going to be, at least in recent memory, one of the worst natural disasters to impact the United States. It is the deadliest hurricane since Hurricane Katrina. It's killed over 200 people, which is probably still going to rise. And economic estimates in terms of damage are around $120 billion, which will probably also continue to rise as more damage is surveyed and then collected and analyzed. Helene was not a very long-lived storm. It was only around for about 3 days. The main thing for Helene, the reason why it took such an awkward track compared to what you would usually expect for a hurricane, was that there was a cutoff low that cut off from the main jet stream up here. I'm using Mr. Tomer Berg's post as an example here. But this cutoff low separated from the main jet stream up here. And as Helene was developing in the Western Caribbean, it was able to pull up Helene and slingshot it into the Florida Big Bend and wrap it around like that, where it finally dissipated as it merged in with the cutoff low. Now, Helene, if we look at this, is actually quite perfect now. Helene, if we study its formation, Helene, the precursor to Helene had to moved into the Caribbean, but then it didn't move into the Caribbean. My apologies. It was the same mechanism that formed Alberto and Chris up here. The Central American gyre kicked up, and 2 pieces of energy got spit out. Helene, what would become Helene, developed in the Southwest Caribbean, and what would become John developed in the Eastern Pacific. John was overshadowed by Helene, but it was another major hurricane that rapidly intensified while making landfall into Mexico, and it did that twice, and dropped a prolific amount of rain. In John's earlier phases, though, when it was rapidly intensifying, that did impart some wind shear over into the Caribbean, so that slowed down Helene from really taking off in the Caribbean. But Helene had the moisture. It had the very warm sea surface temperatures of 30 degrees Celsius or warmer in the Western Caribbean. Translate that into Fahrenheit, that's 86 to 88 degrees. Very warm water. So Helene had it, and it had an anticyclone hovering over it, especially once John's influence weakened, where it had an upper level high over it, giving it plenty of outflow. And this trough up here that we just mentioned earlier also helped to give it some outflow as well. Helene's track started down here, and then it pivoted into, I don't think it made that sharp of a curve, but Helene's track started around Nicaragua, its precursor, and then it got into the Western Caribbean and really started developing. It made a close pass to the Yucatan. It shot right through the gap of the Yucatan Channel, and then it made this right turn as it got slingshotted, and then it was pulled up. I think it's a little bit too far west. It got pulled up into the Florida Big Bend, like this. This was the general just for Helene. Helene was a very large storm. I believe the wind from it extended at least 400 miles away. So when Helene was here, for example, tropical storm force winds were already impacting pretty much the entire state of Florida, with less coverage on its western side because it was moving northeastward. But pretty much the entire state of Florida experienced tropical storm force wind from Helene, and then the hurricane force wind field was about 20 to 40 miles around the center as it moved in. And Helene produced a 20-foot storm surge in the Big Bend of Florida, around Cedar Key, Perry, Florida. And then it moved in into North Carolina, and we know what happened after that. Now, I can probably zoom out. There we go. I'll use this map to help. But once Helene made it into, because it was moving so fast and had a large wind field, the damage Helene was able to do into the interior southeast was tremendous. And as it hooked up into the Carolinas, there was already a predecessor rain event dropping tons of rainfall over the Appalachian Mountains here in western North Carolina, South Carolina, and northeastern Georgia. A lot of rain was already falling in the 3 days preceding Helene, and then Helene just added more rain on top of that and brought hurricane force winds pretty far inland through most of Georgia into South Carolina. Because it was moving so quickly, it was able to keep that energy far inland. So Helene was able to wipe out bridges, wipe out entire communities up in the mountains, and it caused a lot of deforestation, a lot of damage. A lot of people, millions of people were without power. If I can speak, millions of people were without power, and the devastation is still lingering now. And then even after that, after all that Helene did, it dissipated just as quickly as it developed. And then about 2 weeks later, Milton came. Milton did not impact the same areas the hardest as Helene. Helene impacted the interior southeast of the United States the hardest. Milton impacted the central west Gulf Coast of Florida the hardest. Before Milton, though, Isaac was churning up in the subtropical Atlantic. We had Tropical Storm Joyce in the main development region. And then we had Kirk and we had Leslie. Kirk is best described by this image. Kirk was an October major hurricane in the main development region, the latest and furthest east of its intensity so far. And then later, after Kirk slowly weakened, it transitioned into an extratropical cyclone using extratropical transition from the jet stream, and it caused a lot of damage in Western Europe, specifically France and Spain and Portugal. A lot of damage was caused there by heavy winds, by strong winds and heavy rainfall from the remnants of Kirk. Leslie will also follow a similar path where Leslie came up right behind Kirk. It was not as intense because Leslie was also trafficking through the same general area as Kirk. So the cooler water upwell by Kirk weakened down Leslie. So it wasn't able to really get to the same strength as Kirk was able to. But even Leslie still made some impacts over to Europe. The main reason Kirk and Leslie were able to get to their strength was mainly because of the MDR was warm. This is showing June, but by the time we were in late October, the MDR was still very warm. Wind shear throughout this area was very low. The wave train had moved south. The wind shear was very low. Waters were still quite warm. And the temperature inversion in the atmosphere canceled out. So that allowed both Kirk and Leslie, to develop and move out. Develop, get intense, especially Kirk. Kirk was a 150 mile per hour Cat 4 officially, and then they both impacted Europe later on. Milton, on the other hand, did not start here. Milton is actually technically the remnants of a tropical depression that developed in the Eastern Pacific and then crossed over into the Bay of Campeche, reformed, and then Milton developed here. The situation for Milton's a bit different than it was for other storms, for example. Milton was the second Cat 5 of the season, was able to get to 180 miles per hour under exceptional circumstances. Milton formed here and did a slight pinwheel southward, kind of like this. And the water, and number one, the waters in the Gulf were warm enough for Milton. They weren't as warm as with Helene, because Helene had just passed through and cooled off the Gulf a little bit. Not substantially enough to really impact Milton's intensity at all. But usually by October, the Gulf of Mexico begins cooling down enough to where it's harder to get higher end tropical cyclones. You can still get major hurricanes, but it's very hard to get the upper echelon of Cat 5s, for example. Milton was a very small storm, so it was able to do 180 miles per hour and a sub 900 millibar pressure. Because Milton's inner core was so small, and I believe I can show tropical force wind radius if it's available here. Initial wind field. There we go. Right, so I could stop it here. Milton's wind field practically was only 20 to 30 miles wide. Its eye wall was only around 3 to 7 miles wide. Milton was a tiny storm. And because Milton was a tiny storm, it was able to focus a lot of that energy it was getting from the surroundings fairly easily. It wasn't like Helene, where Helene took, even though Helene was a Cat 4 landfall in the Big Bend due to rapid intensification, it still took a while for Helene to build itself up in the Caribbean and in the Southern Gulf to a point where it can really get that intensity. It had to organize itself, and it wasn't rapidly intensifying starting in here. It took a while. It took a while for it to really get its act together before really exploding right before landfall. Milton, on contrast, was already small, so its ability to really rapidly ramp up was much higher than Helene. And then we could see it here as Milton moves southward. We can see the wind field does expand a bit, but Milton is a very tiny system, and because it's very tiny, it's not going to turn up the seas down here that much, which means that Milton can maintain that high intensity and was able to keep going until it had its eye wall replacement cycle somewhere around here. I believe this is... I forgot the name of this reef, but when it passed... Scorpion Reef, there it is. When it passed south of Scorpion Reef, it had an eyewall replacement cycle here, and then it gained its Scott 5 intensity again just north of the eastern part of Yucatan, and where Cancun would be. And then on the day of the 9th into the 10th, as you can see, I'll let this go forward, you can see that Milton's wind field really begins to expand. It really begins to expand here as it's making landfall. So we'll stop it if we can. So why did Milton's wind field expand that way? Two reasons mainly from this. One reason was wind shear was starting to impact the system because wind shear was cutting across the northern end of Milton. That's a terrible arrow. Wind shear was cutting across Milton. Not like that. It was cutting across Milton like this. So that's one reason why Milton created a tornado outbreak in southern Florida that produced gigantic wedge tornadoes. The wind shear was there, the moisture was there, and there was some sunlight to produce violent wedge tornadoes that rampaged through places like Jupiter Beach. I forgot the exact names of these places, but I know there's a significant tornado outbreak about 12 to 18 hours before Milton actually made landfall. So the wind shear cutting across Milton caused Milton to weaken, and that meant its super compact core was no longer going to be this big, was no longer going to be able to maintain its tight donut circle, or the buzzsaws, or a buzzsaw as some people would like to call it. This wind field began to expand as Milton weakened. The worst case scenario that was possible was that Milton would come just north of Tampa, and this would flood. This would force a lot of storm surge right into Tampa Bay, and this would be absolute worst case scenario. What actually happened was Milton deviated south of official track and made landfall around Sarasota, just south of Tampa Bay. That pushed water out Tampa Bay, but Tampa Bay, it actually experienced the worst of the wind and the rain because it was on the northwest side of it. Most of the rain when Milton was on the north and west side, and by the time Milton was, if I can move it here, by the time Milton was here, it was already undergoing extratropical transition, so Milton was already starting to develop fronts at this time, and then because of this, a sting jet was beginning to form where winds up aloft with extreme dry air begin to wrap around center and shoot down to the surface. So that helped on Milton, at least on the southern edge of the storm, wrap around this cooler, drier air coming down from this trough and really rocket it down to the surface as it was making landfall in Sarasota, and that helped really push in the storm surge. Even though Milton was already kicking up a large storm surge as it's getting larger, that really helped bring in the wind and bring in the storm surge further inland, and that helped get storm surge levels of about 10 to 15 feet along the west coast of Florida. Milton, as far as what we know, estimates $85 billion of damage in Florida, because it's the only real place it really affected besides scraping the northern coast of the Yucatan. And then Milton would eventually move off the coast as it moved across Florida with hurricane force winds and large tropical force wind field, and then it will move off into the Atlantic where it became post-tropical and dissipated as it got absorbed into another system. From there, the season slowed down a little bit. After that, we had Nadine and we had Oscar, so about a week after. Now, Oscar is a bit special, I would say. I don't have the exact imagery available, but I'll try to do this like maybe in a full like retrospective video in the future because this is just hands-on. Oscar was not designated until it was just north of the Dominican Republic. Oscar tropical wave came off of Africa, but it looked like a tropical system north of the islands, but wasn't designated by NHC until it was practically already a tropical storm, and it was found that, it was actually a hurricane. Oscar was a very tiny storm and was able to make a landfall in Cuba. Officially it's a Cat 1, but using satellite estimates, it's more likely that Oscar could have been a Cat 2 or a Cat 3 at landfall. There's some satellite evidence to support it. And plus, because the eye was around 3 miles wide and the storm's tropical storm force wind field was about 15 miles or so. I don't think it was 15 miles. I think it was slightly larger than 15 miles. But because the wind field was so small, Oscar was able to rapidly ramp up and keep itself going. Ramp up, be undetected by all the major weather models because it was so small. And then it was able to make a landfall in Cuba. We don't know the exact damages in Cuba because I don't think that information has been released yet. But that's one big surprise this season that people were not expecting. Nadine formed out of another gyre setup here. I believe it was a gyre setup because this looks similar. Nadine formed out of a gyre setup here, and then it pinwheeled westward into the Yucatan. Nadine wasn't super strong, but Nadine dropped a decent amount of rain over the Yucatan and over Central America. Nadine also the remnants of Nadine also became Hurricane Christy in the Eastern Pacific, which was their Category 5 hurricane. So, in essence, tropical depression from the Eastern Pacific became Milton, which was a Cat 5 in the Atlantic, and then the remnants of Nadine became a Cat 5 in the Pacific, which was Christy. Overall, Nadine didn't have a lot of time to really consolidate into a major storm in terms of wind speed, but had it been a little bit slower, it could have added a lot more rainfall. And as we're going to see later, Sarah was a weak tropical storm moving through this area, just a little bit further south, but it dumped a lot of rain over Honduras especially. I saw one report of 90 inches of rain, but I can't verify that right now, so I'm not going to confirm that whether that actually happened. But I know at least 1 to 2 feet of rain did fall over northern Honduras when Sarah passed through this area. But we'll get to Sarah in a bit after I discuss Raphael. Patty also occurred. This was a subtropical storm that occurred in the Northeast Atlantic. This was a bit of a surprise, but it passed through. I believe these are not the Azores. Or are these the Azores? I think these might be the Azores. I'm not sure. They might be. And then Patty will slowly move eastward, become fully tropical here for a little bit. I think it was subtropical or fully tropical here. And then it weakened down as it got closer to Portugal, or the Iberian Peninsula, if you also want to include Spain. Raphael was the last major hurricane of the season officially. Another storm associated with the Central American gyre. This one was also a major hurricane in the Gulf. We will discuss this for a long amount of time. So, Raphael developed once again, due Central American gyre down here. And its development started in the Southwest Caribbean, kind of like around where Helene started. But its organization was slower as it passed west of Jamaica. Environmental factors here were suitable for development, but not for explosive development. Despite the Caribbean still being very warm and easily able to support a high-end major hurricane, Raphael did not have the environment for it, despite having a upper level anticyclone, it wasn't exactly perfect for it. Rafael did begin rapidly intensifying once it passed away from Jamaica and was a Cat 3 hurricane at landfall in western Cuba. And then it weakened to a Cat 2 into the Gulf, but it re-strengthened into a Cat 3 in the middle of the Gulf. After that, though, environmental conditions deteriorated as shear kicked in and dry air came off North America. Oh, that's a terrible drawing. As dry air came off North America as well as shear was covering over the top of Rafael, Rafael kind of just faded away in the abyss of the central Gulf of Mexico. There were people making some fear posts that maybe it could have been an issue for Florida once again. The same thing happened with Sarah, where there was a genuine concern that Sarah, when it was still tropical wave in the Caribbean, models like GFS were showing a loop just off the Central American coast, and then Sarah becoming a bona fide major hurricane high end that would do a movement. I can draw it fully like this. That would do a movement something like this and slam into Southwest Florida. Not there. Here. That was slam into Southwest Florida. That didn't happen because Sarah didn't get its act together fast enough and move further west and move far enough west where the atmospheric pattern just dragged her into Central America, where it dissipated as it moved into the Bay of Campeche, as environmental conditions were not strong enough. Now, the main things that led to this kind of season, I think I can pull it up here. Yeah, I can technically pull it up with this. It's going to be a little bit small, but you guys can see it. The main things that led to the season that we had were the Atlantic was record warm, as you all know. So the Atlantic was record warm. And then we had a developing La Nina. The La Nina was a bit slower this year to develop. It hasn't been super strong based on actual anomalies, but if we look at relatives, there's relative to other basins, there is a medium La Nina in place. There's an actual La Nina in place that's not weak, but it's pretty bona fide. These were the main two things that helped kick off the season. Another thing, I think this might have been earlier in the season, I'm not quite sure. I believe there's a little bit of Atlantic Nino here. I have to go back and really search for it, but I believe there was. So that helped displace the tropical wave jet over Africa further north. So this gave us a more active jet. The only thing is that it was pushed too far north, and then that cut off some of the high-end estimates of 25 named storms. But during this hurricane season, there were very few short-lived named storms. There were not many short storms in the subtropics. Most of the rising energy was concentrated into the deep tropics down here. So most of the storms that developed in 2024 were long-lived storms that had some sort of high intensity, and most of them did make significant impacts. Almost every single storm this year has made a landfall, except for I believe the storms that didn't make landfall this year were Gordon, Isaac, Joyce, Leslie, and Kirk did not make direct landfalls of tropical cyclones, but post-tropical cyclones, they did have their impacts. And then Patty didn't make a direct landfall, I don't believe, but it still impacted land. So basically, there's only about two real storms this year that didn't impact anybody. That is a pretty impactful season. In addition, we've had, due to our atmospheric pattern, we've had not three Gulf landfalls. We've had 5 Gulf landfalls and 2 major hurricane landfalls in the Gulf of Mexico. Florida has had 2 major hurricane landfalls this year. Louisiana has 0 major hurricane landfalls, but has 1 hurricane landfall. And Texas had 1 hurricane landfall, which was Beryl. And Florida had 3 hurricane landfalls total because of Debbie back in August. So that's a general wrap up for the season. Things to look out for next season that we can I can use the bigger map for, which is this. Things to look out for next season to see how the Atlantic's going to react. Sea surface temperature wise, the state of the ENSO is going to be important. Whether this is La Nina, neutral, or El Nino. It's unlikely that El Nino returns again, so most likely into 2025 is either going to be La Nina or it's going to be neutral. Neutral conditions. The Atlantic is likely to stay warm unless something drastic changes. So we're going to keep the Atlantic as a positive. So this will boost activity next year, no matter what. Then other things we have to notice are, for more subseasonal things, will be the PDO up here. This will affect how active the Eastern Pacific is, and this will also help the Atlantic if it suppresses the Pacific. We will also need to know the strength of the West African monsoon, once again, and whether there will be rising air over the Indian Ocean and Africa. If there's more... I need a bigger arrow. If there's more rising air over Africa and the Indian Ocean next year during peak of hurricane season, this will give us more tropical waves that can roll off into the main development region and develop into storms. Another thing, although this is more affects the quality of storms next year, is the dispersion of where the highest anomalies in terms of where the highest sea surface temperature anomalies are. If the highest anomalies are dispersed into the subtropics up here, then that leads to instability issues that hurt development in the tropics and make it harder for storms to develop down here. If, however, the warmth is still concentrated in the tropics like this year, however, then we're going to see more of those long-lived named storms. Long-lived named storms that last a long time and are very intense, where they're located. And then other side things that we'll have to see that it's going to be much harder to forecast out for here. What is the atmospheric pattern over the United States going to be? Are we going to see more of this western ridging? Actually, hold on. Yeah. Are we going to see, I'll draw it in blue, are we going to see more western ridging over the United States, which forces a trough in the eastern U.S.? This matters because then, if there's a ridge in the western United States, a trough in the eastern U.S. will likely steer storms away from the eastern United States, but anything that is in the Caribbean will get pulled up, and we'll see more Gulf landfalls again under this type of pattern. How strong will the ridge in the tropical Atlantic be? Subtropical Atlantic be? As this will affect how strong the trade winds are here during the spring. This will affect whether the MDR actually cools off or not. Strong ridging in the subtropics during the actual season will also determine how many of these storms actually recurve and not hit land. For example. So if we have strong ridging, then a lot more storms will go westward. And then if the ridging is strong enough and we still have this trough over the eastern U.S., they're more likely to get in the Caribbean or maybe into the southwest Atlantic. And then they'll either get kicked off out to sea or they're going to make some sort of landfall. But usually what we've seen, at least as of recent, there have not been too many, especially in terms of major hurricane landfalls. There hasn't been a proper major hurricane landfall in the eastern United States by wind speed in at least 20 years. But if we change the pattern where we're seeing, or we have more of, how would I say it? I can draw this. Where we're not really seeing this ridge in the west, where the ridge in the west may be a low pressure system here, for example. Like maybe there is a ridge, but it's not over the western United States. It's just off the coast of the west. Essentially just off the coast. And you have a high pressure that's sitting over eastern Canada. Then in a situation like this, You can still get Gulf landfalls. This is still definitely a possibility. However, in this case, an East Coast landfall is probably going to be more likely in these type of scenarios because this low pressure system is going to move. And when this storm gets here, it's going to get pulled up. And this will be more of an issue to get East Coast landfalls. But if we see more of the same next year, where we have a weakness over the eastern United States in general, a strong ridge over most of the Atlantic, and over the western U.S., if the pattern continues verbatim like this, then what we can expect to see next year, if more of this happens, is if conditions in the tropics are favorable, especially for the Caribbean, if more stuff forms down here, especially if it's not La Nina, just going to form further west, then we're going to see more Gulf impacts, especially. Whereas getting an East Coast landfall, which usually requires, let me go back, an East Coast landfall usually requires storms to develop here, close to the islands, but not all the way out here, usually. Then this type of storm is more likely to get curved out. Not that close, but this type of storm is more likely to get curved out like that in this type of scenario because of this trough being here. Whereas if there's one here, this one might be able to sneak through. And then this might be an East Coast hurricane landfall, but not a major landfall. Alright guys, that's it for my recap of the 2024 hurricane season. I hope you guys enjoyed it. I typically make long videos like this. I will not edit this video. I'll leave it just as it is. But I will say, this is how I usually talk about things. So I hope you guys understood what happened this season. Talked about pretty much every storm. Talked about the atmospheric dynamics behind what happened. So if you guys want any more explanation, please let me know in the comments. I won't add any timestamps for this video. It's just going to be just me raw talking. And I hope you guys learn something from it. This isn't for most people, but hey, you gotta... If I could try to explain something and people can understand it, I feel I've done my job. So, if you guys have a good day, and see you guys tomorrow.